these are the different series of line spectrum of hydrogen: Lyman series, Balmer series, Bastian series, bracket series, Fund series. This concept I already explained in the previous video. Here N1 is equal to 1 means Lyman series, N1 is equal to 2 means Balmer series, N1 is equal to 3 means Bastian series, N1 is equal to 4 means bracket series, N1 is equal to 5, that is a Fund series. Now N2 is always greater than N1. Okay, here there is a formula that is called as a Rydberg equation. So 1 by lambda, that is also equal to, we can write wave number, okay, that is R, 1 by N1 square minus 1 by N2 square. This formula, it is used to calculate wave number of spectral lines of different series. This formula, it is used to calculate wave number or wavelength of spectral lines of a different series. Spectral lines I already explained. In hydrogen spectrum there are different series. Lyman series, it is observed in UV region. Then Balmer series, it is observed in a visible region. Okay, and then Bastian bracket Fund series are observed in IR region. Now this is called as a spectral lines. Okay, if you want to calculate wavelength or wave number of these lines, then we are using a Rydberg equation. This is called as a Rydberg equation. This calculation is very important. Now I am going to explain how to calculate wave number or wavelength of the spectral lines of the different series. Okay. Now first problem, I will erase this. Now here I will explain the formula first. Now R is a Rydberg equation. Okay, R value is fixed, that is 9677 into 10 to the power 7 meter inverse. Okay, 1.096. I will write it again. 1.09677 into 10 to the power 7 meter inverse. Okay, N1, the value is given here. These are the N1 values for different series. Okay, N2 values. See here, if N1 is equal to 1, then N2 becomes 2, 3, 4, like that, etc. If N1 is equal to 2, then N2 becomes 3, 4, 5, etc. Okay, so I will explain how we can calculate spectral lines of different series. Now questions. See here, this is a question. Okay, now I will read out the question. First question, calculate wave number and wavelength of second line of Balmer series. Calculate wave number and wavelength of second line of Balmer series. Okay, so here the question is asked about second line of Balmer series. Okay, so calculate wave number and wavelength. So according to the question, Rydberg equation, it is 1 by lambda. So this is also called as a wave number. That means we are going to calculate wave number first. Okay, wave number is equal to 1 by N1 square minus 1 by N2 square. Now, so wave number, now R value is fixed, 1.09677 into 10 to the power 7 meter inverse. Okay, 1 by, now N1. So since it is a second line of Balmer series, now for Balmer series, what is the value of N1? That is N1, it is fixed. It is a 2. So for Balmer series, okay, for Balmer series, here I will write first For Balmer series, N1 it is a 2, okay, and N2 it becomes, N2 becomes a 3, 4, 5, 6, etc. It will go. But what is according to the question? Question is asked, calculate wave number and wavelength of second line of Balmer series. Now second line means, see here, N1 it is fixed, Balmer series, that is 2. Now N2 it varies, 3, 4, 5, 6, like that it will go. Now 3 means it is a first line, 4 means it is a second line, 5th means it is a third line, 6th means it is a 4th line, like that it will continue. So for me, which one I want, that is a second line. Second line means which number I should select. N2 becomes, it is a 4, N2 becomes a 4, okay. So here I have to substitute. I hope you understood the concept, how N1 and N2 it is selected, okay. So N1 it is fixed for Balmer series, that is 2. So 2 square according to the formula minus 1 by N2 square. N2 means it is a 4, here it is 4, okay. So it is a square. Now this I will erase. Now 1 point, this I will write as it is, okay. First always you should simplify the number which is inside the bracket, okay. Now 2 square means it is a 4, okay. 4 4 16. Now what you should do, LCM of this number you should take, okay. Here I will take LCM of 4 and 16, okay. So 2 2s are 4, 2 8s are 16, 2 1s are 2, 2 4s are 8, 2 2s are 4, 1, 1, okay. This is the LCM. So 2, this 2, this 2 into this 2 into this 2. What is the answer you will get? 2 2s are 4, 4 2s are 8, 8 2s are 16. So 16 is a LCM, okay. Now this number I will write as it is, 1.0967 into 10 to the power 7. So what is the LCM of this? It is a 16. So here I will write 16, here also I will write 16. So 4 4s are 16, so 4 is remainder, 16 into 16, this it will cancel, so 1 it is left, okay. So simplification, this part I will write it as it is. So 4 minus 1, it is a 3 by 16. So what is the answer you will get? 3 by 16 means, first simplify this, 3 by 16 means your answer is 0.1875 into this I will write 10 to the power 7, this I will write as it is 1.0967, okay. First you have to simplify the number which is present inside the bracket, okay. Now multiply these numbers, okay, with the help of calculator. Multiply. So what is the answer you will get? Okay, that is 0.2056 into 10 to the power 7. This, sorry, here I forgot to write into 10 to the power 7, okay. So answer is, just I will erase and write again, okay. Here I will write. So final answer you got, wave number is equal to 0.2056 into 10 to the power 7. This is the answer, okay. Now it is a wave number, but in the question what is asked? Wave number as well as wavelength. Wavelength is also asked, okay. So this I will erase. So wave number I calculated. Now wavelength. So wavelength and wave number, how it is related? That is, it is a reciprocal to each other. 1 by lambda is equal to wave number. So wave number we already calculated. I will write like this. Okay, wave number we already calculated. What is the answer wave number we got? Okay, so simplify the formula. So lambda is equal to 1 by wave number. This I will shift this side because this part I wanted to calculate. So I will shift this side. Automatically this will come this side. Okay, so lambda is equal to 1 by wave number. So lambda, it is asked to calculate wavelength. Lambda means it is a wavelength. So wave number, new bar, that is already calculated. So 1 by 0.2056 into 10 to the power 7. So first calculate this. 1 by 1 by 0.2056. What is the answer you will get? That is 4.8638. After point only 4 digit is enough. Okay, so this is divided by 10 to the power 7. This is divided by 10 to the power 7. So how we can simplify? 4.8638. Okay, this I will shift into the numerator part. So that time what happened? This is a plus 7. This, while it shift into the numerator, it becomes 10 to the power minus 7. 10 to the power minus 7. Okay, so this is a lambda. Lambda means it is nothing but a wavelength. Now here, since it is a wave number, this it is written in the form of meter inverse. Unit is compulsory. Wave number, it is a meter inverse. This is a meter. Wavelength, that is a meter. Okay, I hope you understood the concept. So writing unit is very important. Second problem, that is calculate wave number of first line of Bastian series. Calculate wave number of first line of Bastian series. Okay, question is asked, calculate wave number of first line of Bastian series. Okay, now here, so wave number is equal to R 1 by n square minus 1 by n2 square. Okay, so what is the n1 value? Since it is a Bastian series, the value is fixed. N1 is equal to 3 for a Bastian series. So I will write. Now N2 becomes, what is N2? It is greater than N1. So greater than N1 means 4, 5, 6, 7, etc. Like that it will go. But question is asked with respect to which line? First line. First line means this is a first line. So N2 value, it is a 4. I hope you understood how N2 value is selected. Okay, based on the line, that is a first line or second line. Based on the line, you have to select the number. Now, substitute the value. Wave number is equal to R means 1.09677 into 10 to the power 7. This number you have to recall. Okay, 1 by N1. N1 means it is 3. N1 square, 3 square minus N2. N2 means it is 4. Okay, 4 square. Now 1.09677 into 10 to the power 7. Okay, 3 3s are 9. 4 4s are 16. Now what you should do? Simplify this. Okay, so for simplification what you should do? You have to take the LCM. I will teach how to take the LCM. This part I will erase. Okay, 9, 16. So 2 first I will take. This I will write as it is. 8s are 2 4s are 8. 2 2s are 4. 2 1s are 2. 3 3s are 9. 3 1s are 3. This is LCM method. You already studied in your lower class. So 2 2s are 4. 4 2s are 8. 8 2s are 16. Okay. 16 3s are, yes, how much you will get? So it is a, what is the answer you will get? 16. 16 9s are 144. Okay, so 144 is the LCM. This I will erase. So here I will write wave number is equal to 1.09677 into 10 to the power 7. Okay, so what is LCM? I got 144. So 144. So it is a 16 minus 9 you will get. So simplify this. This I will write as it is 7 into 10 to the power 7. Now here. Okay. Okay. So 16 minus 9 you will get 7. Divide by 144. So 7 by 144 you will get this answer. So multiply this and this. Okay. So your answer is 0.0533. After point only 4 digit is enough into 10 to the power 7. Okay. Now if you want you can shift the point also, no problem. Now here what is the unit? That is a meter inverse. So since on the wave number it is asked, this is a way of calculation. I hope you understood the concept of calculating wave number and wavelength of spectral lines of different series. I will give a few homework to do the calculation. You have to do the calculation and send me through WhatsApp. This is a homework. I will read out the question. Calculate wave number of second line of Lyman series. I will repeat. First homework. Calculate wave number of second line of Lyman series. Second homework. Calculate wave number and wavelength. Both is asked. Wave number and wavelength of first line of Balmer series. I will repeat the second question. Calculate wave number and wavelength of first line of Balmer series. This is very important question for the sake of exam. Usually it is asked either for 3 marks or for 2 marks. Okay, it is a compulsory question. Thank you.